And welcome to the Daily Space Weather, folks. Looking at 304 angstroms view here of the local yellow dwarf. Bunch of plasma filaments out there in the west. Let's take a quick look at Sunspot 2757 as it sets. Should be our last view of it today. And we've got some more detailed images for you. This is 9 hours and 15 minutes on today, February 1st, 2020. Welcome to the month of February. Here's the 193 angstroms view. Again, it's 9 hours and 15 minutes. Some pretty defined coronal holes down here associated with the South Pole. And let's take a look at Sunspot 2757 in close-up. In all its sunspotty 171 angstroms glory. So still a bit of activity there as Sunspot 2757 sets. And it did produce a little bit of B-class X-ray flares around 1600 yesterday. Let's take a look at the fields real quick on HelioViewer. And there you can see that it looks like it's weakened a little bit here, folks. A little bit less magnetic mixing toward the front end of that umbra, as you don't see any black in front of it this time, as we did yesterday. So there's the view of that, complete with Earth scale. Let's go to stereo A for a quick moment, as we have the situation you see here exactly happening right now. Stereo A located out there in reference to the sun, orbitally behind the Earth, ahead of the Earth in terms of space weather. And here we see Venus moving across stereo A's field of view. And this is the view that we use to determine when coronal mass ejections are headed toward the Earth. Let's look at some more data. There's that X-ray flare we were talking about. Little B-class flare. It is actually the largest flare we've seen out of this sunspot group. Bringing the X-ray flux off the floor a little bit. And let's take a look at it real quick on the GOES 14 X-ray imager. Again, it happened right here, around 1600 yesterday. And it's a fairly slow onset and slow decrease X-ray event. Nothing to write home about. And we see no kind of coronal mass ejections produced. 10.7 centimeter radial flux is still at 74. And that is not solar minimum conditions, folks. It is cycle 25, and our forecast last year was awfully close to being exactly on. KP index has been pegged at 1 for nearly a solid day. Let's take a look at cosmic rays. First via the Apatity neutron monitor. There's the last 24 and 30 days out of that. And down here is Barentsburg. And they've both moved into a nearly flat for the past 30 days profile. And next we'll take a look at Athens. Athens, Greece. One of the neutron monitors that we frequent. Also looking flat over the past 30 days. And there's the info from Mexico City. Also quite flat over the past 30. And this is one of the ones that you can access the archival data. Feel free to look it up if you like, to learn that cosmic ray flux was higher at the last solar minimum, despite what various YouTube channels may tell you. Moscow isn't really sending data, so we're going to skip it. And lastly, probably the most popular cosmic ray monitor in the world, Oulu, Finland, also looking flat over the past 30. And we'll also look at DOMC Antarctica, but not DOMB Antarctica, as it's not sending data. There is DOMC, a downtick over the past 30 days there. And we always leave the links to the Network of Cosmic Ray Station site that we use to link to these stations. If you want to monitor them yourself, click the links below the video. Next, looking at the real-time solar wind, we see the phi angle and the BT-BZ have just started shifting around as we did show prep. So we could be magnetically connected to that coronal hole system right now, folks, as we see a phi angle very close to 180 degrees, where the plasma in the solar wind is informing us of the angle of the magnetic field. And by the way, the plasma is not becoming the magnetic field. Floating clouds of gas and dust do not become stable magnets. They get heated up and moved around by magnetic fields. They are not the magnetic fields. Plasma aligns to the fields. Plasma is not the field's generation source. Solar wind density, 2.83 protons per cubic centimeter here. Quite low levels there. And we see a small ramp down of the solar wind speed over the past 24, but it remains elevated at 462 kilometers per second. There's the data from ACE, looking quite corroborative. We're expecting this to weaken throughout the day today. Next, we'll look at geospace magnetosphere movies. 4 hours of data here, courtesy University of Michigan. And since this data is not accessible in archive form, we show you 4 hours each day. Occasionally, we will do an impromptu video because of a coronal hole wind stream hit or a coronal mass ejection. Right now, everything's pretty steady and looking fairly normal on the geospace magnetosphere movies. Nothing too exciting happening there. Let's look at ground magnetic perturbations. Delta B, in other words, changes in the Earth's B field. That's the field passing through the magnet, not to be confused with the Earth's Z fields, the ones that occur at the poles. Anyway, there's 4 hours of data during this magnetic excursion. Welcome to the magnetic excursion and indeed the neo-renaissance, folks. Have you looked at smashomash.com/forum yet? There's all kinds of vital information there. Or maybe you'll find it to be irrelevant information, but check it out anyway. And post something. Go ahead, post something. I dare you. Relativistic electrons have finally jumped up as anticipated, and we're expecting this to reach much higher levels than this over the next 48 hours. And there's the GOES electron flux off of its utterly cratered levels that it was at a few days ago for an extended period of time. So welcome back, electrons. Next, we're going to learn how to speak English and look at the ionosphere. This is 6 hours of data, and you can see the time and date stamps up there. We do see continued measuring errors on the prime meridian. Not sure what's causing this. We've been seeing it for several weeks, as well as nighttime charge-up events of the ionosphere over the South Pacific west of South America. And let's not dwell on it. Let's move on, as there's plenty of other things to talk about. Links to this below the video also, if you want to monitor it yourself. There is the most current data, and you can see right now there's a 8 megahertz charge zone out here in the South Pacific, centered on the negative 30 degrees latitude line, and it's been there for months on the daily. GOES magnetometer is a little smoother here, and there are some interactions going on right now with the solar corona, and we'll show you what's happening with it in a minute on the Gong 2 data. But there's the GOES magnetometers, and happy to see the GOES 16 back online. Here's the Gong 2 data, and this really shows us a lot of extra magnetic data here. And you see these areas in between the Earth and the Sun right now. These are areas of bunched up plasma, and plasma does prevent the detection of magnetic fields, which again does not make it a magnetic field. Plasma does have the ability to react with things like electrons. It does have the ability to obscure things that are behind it. But plasma is not, and is not going to be, a stable magnetic field, as magnetic fields simply heat up the plasma and move it around in space. Plasma is not magic, and everything is not electric. We're going to do a second cosmology video. We're going to do a cosmology segment video. Anyway, there's the latest on the Gong 2, and the South Pole has completely taken over the charge of the current sheet in that video, in that frame. Keep in mind the data is 1 hour and 10 minutes old, and magnetic environments can change with absolutely no warning. Let's talk about Mauna Loa, the world's largest active volcano. And if it erupts in an epic fashion and drops the Earth's temperature 1 degree Celsius, billions of people will likely die. And the reason we're looking at it is because, once again, as we've been documenting for a couple of months now, we see earthquakes happening at depths of negative 2.6 kilometers. Well, what does that mean? That means that it's occurring 2,600 meters above sea level. So if you look at the interactive maps here, and you zoom way in to Mauna Loa, you can see that the top of the caldera is at about 4,172 meters, which means that earthquake happened about halfway from sea level to the summit of Mauna Loa. And while it was small, it indicates a filling of magma chambers. And let's head to the list here at USGS and just run down the whole list. No 6 magnitude quakes over the past 24. Several 5s. Some activity there around Samoa and Tonga. There's one, I believe that's the Canary Islands. It's a 4.7 magnitude, and we're just going to scroll up the list here. Nothing too noteworthy that I see yet, at least. There's a deep one at the Mariana Islands, 115 kilometers. There's a very deep quake, and the largest of the past 24 appears to be this 5.7 near Fiji at an extreme depth of 575 kilometers. If that happened at the surface, that would be somewhere in the realm of a magnitude 7 earthquake, folks. There's another shallow quake at Hawaii, that one occurring 1,800 meters above sea level. And we've got more information on Mauna Loa coming momentarily, so stay tuned for that. This 5.3 did occur just northeast of Tokyo. Could have caused some damage, something to look up throughout the day today, perhaps. Here's another deep quake at Indonesia, 226 kilometers and a 5.0 magnitude. A couple quakes in Western South America, as we typically see. And there is yet another deep one. Still making Western South America my favorite spot for the next really big earthquake, as we really are experiencing a drought of large earthquakes, folks. Again, there's that quake right underneath the caldera of Mauna Loa at 2,600 meters above sea level, about halfway from sea level to the peak of the mountain. By the way, there is expansion happening there also, but we don't really see any gas venting or anything yet. Let's hope the world's largest volcano does not erupt in an epic fashion. And here's some more information about Mauna Loa. There is a webcam up there. It is aimed to the north, so it's not really looking at the caldera. But anyway, let's go to windy.com's pressure map here and check out the pressure environment. And this is the GFS forecast. We're going to let this advance about 24 hours. By the way, windy.com has a great mobile app. It's free for your smartphone. Just check it out at windy.com. I won't recommend you to any other places to download software. Maybe CNET, but certainly not certain vendors. Anyway, there's where we expect things to be via the GFS forecast at 1500 Universal Time tomorrow. If you're wondering what time it was when we made the video, it's 4:42 a.m. And just to reiterate, there's where that very shallow, and when I say shallow, I mean a couple thousand meters above sea level, occurred. Quite underneath Mauna Loa's caldera. So something to keep an eye on. And when I say ion, all right, there are ions. Let's talk about the rest of the volcanoes going off. Mount Aso erupting, flight level 6,000 there. Kuchinarabu-jima, flight level 3,000 there. Sakurajima exploding, flight level 9,000 there. Dakono exploding. Continuous volcanic ash emissions producing a 7,000-foot ash plume. And let's just read it. During the past week, HVO seismometers recorded 107 small magnitude quakes beneath the upper elevations of the volcano. The strongest was a 2.3 magnitude on the 23rd. Looks like they got to update their information here on Volcano Discovery, as the one we just showed you was at a higher altitude than that. Global positioning measurements show continued summit inflation, consistent with magma supply to the volcano's shallow storage system. Gas concentrations at the sulfur cone monitoring site on the southwest rift zone remain stable. Fumarole temperatures as measured at both sulfur cone and the summit have not changed significantly. Expansion is a serious thing though, folks. Let's hope we don't see any major venting coming out of Mauna Loa, as volcanoes are a global cooling input, and the northern hemisphere is covered with snow, once again, for the third year in a row. Popocatépetl, new emissions from there. Fuego, new emissions from there. Sangay exploding, flight level 19,000. Revenador has dissipated its volcanic ash, and we see ongoing emissions at Sabancaya, so please do not attempt to do the Fosbury flop. That's how you do the high jump, folks. Please don't attempt to do the Fosbury flop over Sabancaya. And let's go to human health real quick. Coronavirus cases are approaching 12,000. And we've got all kinds of information on smashomash.com/forum. Set yourself up a login there. And I would note that we do not see cases outside of China rising. I believe these are underestimated. Everybody believes these are underestimated, as when you quarantine tens of millions of people, it's going to be difficult to get confirmed cases. Let's hope we don't see either of these graphs continue to increase in their steepness. You want to read more about it? Again, check out smashomash.com/forum. Thanks everybody for setting up logins for that and so on. It's been a wild success. And there is talk of the possibility that coronavirus could be a weaponized virus, as there is a top-level biolab in Wuhan. And we're not going to get into it too much, but again, check out smashomash.org. Scroll down, there's a link to smashomash.com/forum. Let's talk about the albedo effect. Are you aware that things like snow and clouds are global cooling inputs, and that the albedo effect is a positive feedback mechanism, meaning if it reaches a tipping point, you get a snowball Earth, and that a snowball Earth is the primary phase of the planet over the past several million years? Were you aware that Antarctica, the glaciers, the ice on Antarctica, the ice sheets, they formed 33 million years ago when the temperature was 3 degrees Celsius warmer than it is right now? Let's talk about how it's not understood, the albedo effect. And let's talk about this phys.org article. As our planet gets greener, plants are slowing global warming. Survey said. What's the ridiculous theory on how plants are slowing global warming? It's by removing carbon dioxide from the atmosphere, which a lot of people believe is the climate control knob of our planet. What do you think? Do you think carbon dioxide is the climate control knob of the planet? Survey said. Are you aware of the albedo of plants? Do you think that carbon dioxide is the control knob of the planet, folks? Oh, look, another ridiculous motion. Plants are also wetting the atmosphere through transpiration of groundwater and evaporation of precipitation. Survey said. Anyway, links to the ridiculousphys.org article below the video. And check it out, Science Alert is getting into the Act 2. These 4 graphs explain why we can't blame climate change on solar activity. Do you think we can blame climate change on solar activity, folks? So let's look at these graphs a little bit. Sea surface temperature is a good indication of the Earth's overall climate, right? Survey said? Okay, maybe not. Measuring the Earth's atmosphere is a good indication of the Earth's overall climate. Survey said? Anyway, folks, this is all nonsense designed to get you to believe that carbon dioxide is causing the planet's temperature to rise, which is complete nonsense. Have you ever gone to the doctor and had the doctor measure your temperature by having you blow into a breathalyzer? What's that? What's that? No? Well, this is the reason why measuring the atmosphere is a ridiculous idea in terms of measuring the Earth's climate. We need to know the temperature of the Indian Ocean at 3 meters, and that is why surface temperature measurements of the ocean are complete nonsense. This has to do with the latency of heat of water. You ever notice how it takes a very, very long time, thousands of years, for water to heat up and cool down? Well, in order for the sun's effects to hit the climate, it takes about 2 to 3 years of lag time. So after a solar minimum, the planet stays cold another couple of years before the latency of heat in the oceans begins to catch up with the solar forcing. And also keep in mind that magnetic fields have a massive effect on the way the jet stream is oriented. Links to the Science Alert article also below the video. Don't lose an IQ point reading it. Have some discernment, folks. Have some discernment. Now, we covered the ice on Greenland all summer long, and here are satellite images that you can look at from the Danish Meteorological Institute all around the coast of Greenland, wherever you'd like to go. So perhaps monitor it yourself. By the way, if you're wondering how much ice was or how much snow was covering Greenland in August, it was 9 feet nearly from coast to coast all summer. Greenland is not melting. Neither is Antarctica. Here's the sea ice thickness, courtesy of Polar Portal. And this should be animated here. I don't know why it isn't. Anyway, there's the animation of the Arctic sea ice, and you can see there's still ice there. It's at pretty low levels right now in terms of the overall ice volume. And this is an absolutely normal variation. We've linked to this page also below the video. You can run animations from various different dates here. So perhaps go look up the data yourself. Don't take our word for it. I'll just let that run through again. I believe that ends on the 30th or the 31st. And it sure looks like there's ice up there to me, as we see record snow all across the northern hemisphere once again. Here's where lightning's striking. I like to use lightningmaps.org. It's a great source for real-time lightning maps. And pretty calm in terms of lightning right now. Let's look at some more weather data. Here is the U.S. Doppler radar animation. And that atmospheric river is finally hitting Washington in a big way, as there is a stagnant, heavy system of rain right in the nation's northwest corner. Some snow continuing to hit New York and New England. And let's look at the water vapor map. And there's that data. You can see that all that moisture over Montana starting to swirl around now. And we've got some cold air being injected into the central U.S. And let's look at a convergence over Florida for once. Shout out to Mothra. Now, my mom lives near Oviedo, Florida, and we see some serious convergence. I would note all those Hall streamers. You see all those lines that are perpendicular to the mode of motion of the water in the atmosphere? Yeah, those are Hall currents, folks. And this is part of the reason why we look at this every day. because not all things are electric, but the Earth's atmosphere certainly is, as it is the capacitor between space and the lithosphere. And now we're at null school, and you can see that extreme bend in the jet stream that we were talking about, pulling cold air down over the Great Lakes and so on into central U.S. Extreme meridional jet stream bends. We have a doubled up jet stream over the Atlantic, and we've got some backwards jet stream flow over eastern South America down there. Check it out. It's a tripled up jet stream, and we've got incorrect. We've got it flowing east to west, which is not normal in any way. Here are the jets of the eastern world. Big time kinks in the southern hemisphere portion of it also. We've got some more stuff for you here. First, let's talk about YouTube. Please consider pressing like and subscribe. Check out our related content channels. And please share on your social media, as we're stagnating at 1,400 some subscribers. Now, if you're considering trying crypto, click the links below the video. There's one to a Coinbase link. You get $10 of free crypto just for signing up for a free account at Coinbase. You can cash it in right away. So consider using our links, earn some free crypto, and I can still earn $186 more in free crypto just by learning about different types of cryptocurrency. There has recently been an uptick, so hey, perhaps wait until there's a downtick. But if you're thinking of dipping your tippy toe into the lukewarm, tepid pool that is cryptocurrency, use our link and earn 10 free bucks. If you'd like to support the mission, which is available at smAshomash.com/forum, please consider becoming a patron. We've only got 2 levels, the $1 and the $9.99 a month. So consider being an assistant or associate producer of the content. Thanks, Smash Team. We've got a bonus of features. Have you watched our cosmology segment? I don't know how we're only at 84 views with this. It's a very important thing about poloidal versus toroidal fields, as there is a blatant lack of understanding of how these things relate. So watch our cosmology segment at youtube.com/smashomash/videos. In fact, we've even featured it as a featured video on the main page. So just head to youtube.com/smashomash and watch the cosmology segment if you haven't done yet. Let's look at the 94 angstroms view here. We're going to do the 48-hour video, and then we are going to be out to watch the premiere. Thanks for everybody who tuned into the premiere, by the way. Look for a second and possibly a third video coming out today, certainly a cosmology segment, and it might be extended. There's the extended view of Sunspot 2757 as it sets in 94 angstroms. A little bit of activity there in the north portion of the sun, and we're going to be doing more extensive videos on HelioViewer and so on. A little bit of bright spot coming out of that coronal hole in the southeast down here where my pointer is. Anyway, we're out. Thanks for tuning in. Don't forget to stare at the sun. Don't drink it. If you do, don't drive. And since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.